An isotope of an element has a half-life of 15 hours. Initially, there is 25 grams of the isotope present. Part A says, write the exponential function that relates the amount of substance remaining after T hours. In general, our half-life formula is A of T, I naught, which is our initial value, then 1/2 raised to the power of T over, and I'll label it as HL for half-life. So the T over HL is in the exponent that belongs to the base 1/2. So the problem tells us that we're starting with 25 grams. So our formula specifically for this situation is going to be 25, because that's our initial value, times 1/2 raised to the power of T over 15. And I put 15 in there because that was given up here as our half-life. And then here's our I naught, that initial value. So this is our formula for the half-life with this situation. So I plug in T. So T is the number of hours that have passed, and then it gives me the amount that's left. Now in part B, it says find the rate in which the substance is decaying after T hours. So they're asking us for the derivative since they're asking for the rate. In general, if I have an exponential function, b to the x, the derivative is going to be b to the x times the natural log of b. And then, of course, the chain rule would hold true for this rule as well if there was something other than x in the exponent. So for this specific example, when I take the derivative of our formula from part A, this is an exponential function. So I have that A prime is going to be 25 times 1/2 raised to the power of T over 15. Then I have to multiply that by the natural log of my base. So that would be the natural log of 1/2. And then also because of the chain rule here, I have T over 15. So I have to multiply by the derivative of that, which would be 1 over 15. Now, when I clean this up a little bit, I have that the derivative is going to be 25 natural log of 1/2 all over 15 times, and then I have my exponential function 1/2 to the T over 15. So we're going to use this information in part C. So let me carry that down. Here's our derivative. I have 25 natural log of 1/2 all over 15 times 1/2 to the power of T over 15. This question says determine the rate of decay at 20 hours. I want to plug in 20 for T to find my rate. And actually, let me plug it in here too. I should be doing that as well. Okay, now I'm going to put that in on the calculator. The question says to round to 4 decimal places. So when I put this in the calculator and round to 4 places, I'm going to get approximately negative 0.4585. And because this is measured in grams and the time that has passed is in hours, we're going to write our rate as grams per hour. And we have a negative here because this is going to be decreasing, right? The rate in which that substance is left is going down. We're going to start with 25, and then every 15 hours it's going to get cut in half. So that substance is, the amount of substance, I should say, is decreasing, and that's why this here is a negative.